Alright, in this video we're going to look at the periodic table of elements. This is something you've probably seen in a picture in a textbook, or maybe even hanging up in a science classroom or the science lab. If you go to Mr. Harbour's classroom, there is a picture of it hanging up there as well. This is something that could be potentially really boring. However, when you go to look at it and further explore about the periodic table of elements, if you are really wicked cool, you'll realize that the periodic table of elements is actually an amazing organization of the elements. And what we're going to do is we're going to look at this history of the periodic table of elements. As you watch this video, what I would like you to do is fill in the blanks on your handout. I will be going somewhat following the script of your handout, but you may also need to stop the video at times and think about what best fits in the blanks. So just follow along and pause the video as you need to. So in this wonderful picture we see two guys, obviously from a long time ago, sitting around. The one guy says, "Are you Dmitri Mendeleev, the father of the periodic table?" And as a kind of quirky joke, if you get it, it says, "I am." Those are two elements from the periodic table, and they're two symbols from the periodic table. So, ha ha ha, very funny. Hopefully you get the joke and you like the joke. If not, that's too bad. Alright, so the modern periodic table of elements was largely developed by this guy named Dmitri Mendeleev. He was a Russian chemist and a teacher who wanted to make it easier for his students to learn about the elements. So he was teaching his students, and they weren't getting it, or they weren't getting as excited as he was. He was pretty excited about the elements and chemistry, and he actually became quite obsessed with the elements and organizing these elements as well. So by the 1860s, when Mendeleev was doing his work, there were about 63 known elements. So our periodic table of elements today has a lot more than 63 elements, but back in his day, it was 63 elements. At this time, there wasn't a good way to organize the elements, other than a list of properties of various elements. So imagine these 63 elements here, as you see in this screenshot. There's 63 elements. They're laid out on the table, but they really have no way of organizing them. So one of the first ways that they tried to organize the elements was by organizing them by weight. So again, here's an example of what it might look like if those 63 elements or those 60 elements were organized by weight. Doesn't really look useful to me. However, if you had a chemistry background, it may be useful. So what I would like you to do right now is stop the video for a minute and think about why Mendeleev may have wanted to organize the elements. So what was the purpose of organizing them rather than going in alphabetical order, or just having a list of them? Why was it important to have some sort of other organizational tool or organizational form to organize them? So how did Mendeleev go from just a simple list of elements organizing them to weight, to the final structure of what the periodic table of elements looks like today? What he did is he used information that was known about these elements, so including the properties like atomic mass, color, density, melting point, and how it reacted or didn't with other elements. And he used these to sort and organize the elements in some form or fashion. So Mendeleev's first periodic table would have looked something like this. To us, in not knowing the properties and understanding the properties, of the periodic table, it really still doesn't look clear. It doesn't have any clear organizational factor to us. It may look like a whole bunch of numbers and letters put together that mean absolutely nothing. However, as he sorted and organized the pattern, a pattern developed. So he realized that the metals ended up on one end, on one side. Non-metals were in the middle, and then, metalloids were also in the middle. So if we look at the modern day periodic table of elements, again, based on Mendeleev's organization, we can see that there are metals on the one side. So those are all metals. Then on the other side, they are non-metals. And these ones in between here are called the metalloids. So they're in the middle. In your notes, it says non-metals in the middle and metalloids in the middle. That doesn't make sense, obviously. Metals are on one side, non-metals are on the other side, and then in the middle, or the staircase, those are called the metalloids. As you see at the bottom here, there's more categorizations. However, in Science 9, we just have to understand the basic categorizations. So metals, non-metals, metalloids. We will be looking at halogens and noble gases later on, and then specifically looking at the alkaline metals and alkali earth metals as well, more specifically just to determine the different characteristics. So as he further grouped the elements, he found common characteristics. So for example, sodium and lithium, right found here on the periodic table of elements, sodium, lithium, and these other metals reacted very violently with water. So they were grouped together in a group. What I would like you to do right now is just pause the video, think back about what you have learned, and write down how he organized the elements and what patterns he discovered. After working with the organization of the elements, Mendeleev was so confident in his organization of the elements that he left gaps in the table if he could not find an element that had the right properties. So basically these gaps, he was predicting that there were elements that were yet to be discovered. So all of these question marks here, he predicted were different elements that hadn't been discovered yet. He was so confident in this, and it was actually proven when germanium, was discovered in later years. Its properties had the exact match to the properties that Mendeleev's table predicted. So yet another reason why this periodic table that Mendeleev had created is so awesome and amazingly with the organizational factor. Not only does it help OCD people like me with organization, and it makes a clear pattern of the elements, but he also had proof to back it up, and that makes it ridiculously awesome. So, we should thank Mendeleev for the awesomeness of this periodic table. Although it looks pretty boring, and it can be pretty boring, it actually is quite amazing. So in the next activity, you are actually going to explore these patterns of the periodic table and what it actually does to organize the elements, or how the elements are organized, pardon me. So what I would like you to do right now is stop the video again and just answer the question as to how Mendeleev's organization system was proven to be a good way of organizing the elements. So think about these gaps, and how did these gaps help support and strengthen his way of organizing the elements. Right, so now that you've answered the question or the questions in the booklet, and you have a general idea of Mendeleev's organization of the periodic table of elements, I think we should declare the rest of the month of September as the Mendeleev month, just because he is so ridiculously awesome, and we have so much to owe him for. So he is awesome, the periodic table is awesome, and we need to remember that as we are learning about how and what the periodic table has to offer us.